Example problem 5 reads, a weather balloon contains 222 liters of helium at 20 degrees Celsius and at 760 millimeters of mercury. What is the volume of the balloon when it ascends to an altitude where the temperature is minus 40 degrees Celsius and pressure is 540 millimeters of mercury? So first of all, the balloon is ascending to an altitude that is higher than where it currently is. So that means that there is a change in conditions and that we are going to be using P1 V1 over T1 equals P2 V2 over T2. Sometimes you can't eliminate a variable from the combined gas law. Sometimes you actually have to use the whole equation as the combined gas law instead of eliminating a variable. And this is an example of one of those kind of problems. Every variable that they give you in this problem is important. So we know that we're going to have a P1, a V1, and a T1. And we're going to have a P2, a V2, and a T2. So the weather balloon initially contained 222 liters of helium, so that's a volume, at 20 degrees Celsius, that's the temperature, and at 760 millimeters of mercury, that is a pressure. What is the volume of the balloon? So we're going to be looking for V2. When it ascends to an altitude where the temperature is minus 40 degrees Celsius, so minus 40 degrees Celsius is your T2, and pressure is 540 millimeters of mercury. So 540 millimeters of mercury. So we technically could use millimeters of mercury in this problem. You don't always have to go to ATM. However, I prefer you guys to convert to ATM because whenever we do the ideal gas law, PV equals nRT, which is next, you're going to have to convert to ATM. So I'd like to get you guys used to converting to ATM on the front end. That way these problems are easier whenever we do them later in the chapter. So that being said, I want us to go ahead and convert pressure into ATM. So the first pressure we don't have to do anything with because the conversion factor from ATM to millimeters of mercury is that in 1 ATM, there is 760 millimeters of mercury. So there's nothing that we have to do there. We do have to do a conversion over here on the second pressure because it's 540 millimeters of mercury, not 760. So millimeters of mercury goes to the bottom and ATM goes to the top. And so we just said that in 1 ATM, there is 760 millimeters of mercury. So millimeters of mercury cancels and we're left with ATM. So in your calculators, 540 divided by 760 equals 0.710, so 0.71 ATM, and that's going to be our new P2. So we do have to convert temperature to Kelvin. That's absolutely no choice with that. Always has to be in Kelvin. So 20 degrees Celsius plus 273.15, 20 plus 273.15 is 293.15 Kelvin. And so T2 minus 40 plus 273.15. So let's put that in our calculators. Minus 40 plus 273.15 is 233.15. So 233.15 Kelvin. Remember, it's not degrees Kelvin, it's just Kelvin. So we can go ahead and start putting everything into the big P1 V1 T1 equals P2 V2 T2 equation. So our P1 is 1 ATM. V1 is 222 liters, and liters is okay. That's the correct unit for volume. Divided by T1, which the new T1 was 293.15 Kelvin, equals the new P2 was decided to be 0.71 ATM. V2 is X, that's what we're looking for, divided by the new T2, which is 233.15 Kelvin. So since we didn't cross multiply last time, I'm going to go ahead and cross multiply this time to show you guys how to do it, in case you've not had this in your algebra classes yet. I know some of you guys are currently enrolled in algebra now, since it's a co-requisite for the class, and so you may not have learned how to do this yet, so I'll go ahead and show you. So it doesn't matter if you start with the top or bottom, because you're going to multiply like this. So we'll just go ahead and start with the top here. So going down this way, 1 times 222 is 222, so you don't really have anything to do there. But 222 times 233.15 is a really big number, and that's okay. I don't want this to scare you guys, because a lot of people will look in their calculator and say that's a massive number. I know I did this incorrectly. No, you did it okay. So the number is 51,759.3, and so it's ATM liter kelvins. So ATM liter kelvins. They didn't go anywhere. Equals, we're now going to handle the other side. So 293.15 times 0.71x is going to be, so in our calculators, 293.15 times 0.71 is 208.136. 208. It's 136, so we'll go with 14. And the x doesn't go anywhere, and neither do the units. So this is going to be ATM Kelvin times x. And so that's how you cross multiply, and you end up with the same straight line equation that you would working this problem that we did the previous way. So to isolate x by itself, you would divide by 208.14 ATM in Kelvin, and that cancels. So divide by 208.14 ATM Kelvin, and so here you can see with the liters with the units that ATM cancels, Kelvin cancels. We're left in liters, which is appropriate for volume. So in our calculators, make sure that we carry every number. We don't forget anything in that big number on top. So 51,759.3 divided by 208.14, and that gives us a P2 of 248.675, so we'll say 0.68 liters. Sorry, this is a V2, not a P2, because we are searching for V2 and liters is the units that remained. So 248.68 liters. Let me know if you have any questions about example problem 5.